Okay, bonus extra video as we skipped over something in class, just to make sure you can see a technique explicitly that might have gone wrong for some of you. So we're trying to find values a and b in the set of real numbers such that this is true. So step one, expand this bracket, collect the terms. I think you get 2a take 3i plus 4abi plus 6b, and that still equals 9 plus 3i. And as we mentioned and pointed out, and you agreed with in class, if two complex numbers are equal, that means the real parts are equal and the imaginary parts are equal. So the real part of this is 2a and 6b, they're the bits without I in, and that must equal 9. So that's just taking these real parts and separating them as their own equation. The same with the imaginary parts, and I'm going to swap the order to make it positive. We get 4ab take 3 is 3. So now this pair of equations we can solve simultaneously. Unfortunately, because we've got this product in here, it's going to be substitution, which is going to take a bit of time to do. So we'll rearrange this to get 4ab is 6. Divide through by 4b, and we get a is 3 halves of b, because I've already cancelled the 6/4 of the fraction. We'll now substitute into the real, so we'll substitute this a for this expression here, which means the 2's will cancel. So we'll get 3 over b plus 6b is 9. So far, so horrible. We'll multiply through by b. To get 3 plus 6b squared equals 9b. And from there, we're going to need to rearrange that to make it a nice, neat quadratic to solve. And so from there, we are going to subtract 9b from both sides and divide 3 by 3 at the same time. So we're going to end up with 2b squared take 3b plus 1 is 0. That, it happens, factorises, but if it doesn't factorise, you can complete the square or use quadratic formula or get any solution, in which case you get b is a half or a third. Okay, and those are both real numbers, so they're both valid solutions, which means a is, where's a? A is here. Is that on the screen still? No, a is here. So a is 3 divided by 2 lots of b. So 3 divided by 1 is 3. Or 3 divided by 2/3 is 9 halves. So that means we have a pair of solutions. A, B is a half, no, is 3 a half, or 9 halves, a third. Sometimes you won't have two solutions, sometimes you only have one. But that general principle of expand things out, collect terms, and then take the real part and the imaginary part separately. The equation you get here may be more or less complicated, but your algebra can do that, I'm sure. I've got faith in you. Everything else in that exercise looks okay, except of course the super hard red question, which is designed to test you anyway, so I'm not particularly fussed if you don't find that easy. You're meant to find that tricky. So, enjoy that if that's your sort of thing.